Good morning to all. Today I am going to talk about Bingham method. The other name of Bingham method is penalty method. The problem is the given problem is the maximum is z equal to 2x1 plus x2 plus x3 subject to the constraints 4x1 plus 6x2 plus 3x3 is less than or equal to 8, 3x1 minus 6x2 minus 4x3 is less than or equal to 1, 2x1 plus 3x2 minus 5x3 greater than or equal to 4, and all the variables is positive or equal. In this problem, two less than or equal to constraints and one greater than or equal to constraints. So the less than or equal to less than or equal to constraint means to add the slack variable, and greater than or equal to constraint means to add the surplus variable. So slack variable, we have two slack variables and one surplus variables. So the given equation is changes to maximize z equal to 2x1 plus x2 plus x3 plus 0s1 plus 0s2 plus 0s3. We have three to add three variables s1, s2, s3, and the constant value is 0. Subject to the constraints 4x1 plus 6x2 plus 3x3 plus s1 equal to 8, and 3x1 minus 6x2 minus 4x3 plus s2 equal to 1, and 2x1 plus 3x2 minus 5x3 minus s4 equal to 4. In this problem, we have only one surplus variable. So every surplus variable of the penalty method to add the artificial variable, we have to assume the artificial variable is R1. So the first two equations are same, but the third equation is slightly changed. 2x1 plus 3x2 minus 5x3 minus s3. We have surplus variable, so to add the artificial variables r1 plus r1 equal to 4, and all the variables is positive or equal. Initial iteration, already we have told the some simplest method problem, so the initial iterations are same. The topmost value is Cj, and the for Cj means the in a maximized profit value, the coefficient of the maximized profit value is not right. So corresponding x1, x2, x3, s1, s2, s3, and then artificial variable r1. So the every artificial variable to the coefficient is minus m. So the first column is Cb. We have to we have three variables s1, s2, s3. In this case, s3 is the surplus variable, so to add the new artificial variable, so you have to add the artificial variable r1. So the coefficients are s1 by 0, s2 by 0, and r1 by minus m. Next, xb. xb is the RHS value of every equations. Remaining are x1, x2, x1, x2, x3, x1, x2, s3, and r1. These are the coefficients of, you have to fill the coefficients of the values. Also, you have to find Zj minus Cj. Zj means xb into Aij. Aij be the coefficient of the every equations. You have to find the ratio and the most negative value in this problem. In this problem, Xj minus Cj is less than or equal to 0. So the current position is not optimal. So to go for the next iteration, you have to choose the leaving variable and the entering variable. In this problem, the leaving variable is R1. R1 is leaving variable, and the entering variable is X2. X2 is the entering variable. The leaving variable is R1. In the first iteration, R1 is removed. So in this problem is based is equals to the simplex method. So you have to find the simplex method. And the another one is condition is the ratio. Every ratio value is always positive. If the value is negative, to not considered. Okay. So the first iteration, the zero is the ratio value, because of remaining two values are negative values. So to omit the values, not a row, to omit the values only. So you have to choose the zero. This was the three iterations. The third iterations, the value is always positive. So the maximum is z it x64 by 21, and x1 value is 9 by 7, x2 10 by 21, and x3 0. Thank you.